All right, people. So I'm going to talk to you about hybridization. Hybridization. Sometimes you'll see it spelled with an S, and sometimes you'll see it spelled with a Z. Depends on what type of English you speak. Okay. What is that? All right. Here we go. We got room for that. All right. Now, when we talk about hybridization, I'm talking to you about hybridization of the carbon atom. The carbon atom inside of a molecule, like an organic molecule. So there are many different ways that carbon's going to bond. And one thing you know is that anytime you have this carbon, it's going to have 4 lines attached to it, right? Carbon is always going to make 4 bonds. So let's talk about carbon, right? Now we can talk about maybe CO2. We can draw this. And we could talk about maybe, I don't know, CBr4, carbon tetrabromide. And then we could say, let's see, this has got 2 doubles. So we could talk about maybe H2CO. So here we go. These are 1, 2, 3 different molecules we can do. And I can show you the hybridization, or how the orbitals in this carbon atom change. All right? Now, if we did CO2, I'm going to write these over here, so we're just going to keep these over here for later. All right. So, CO2, first thing you need to do is draw yourself the Lewis structure. So CO2 is going to be like this. And it ends up being a linear molecule, right? And now we have to label these. We know that the first bonds are called sigmas, and the second ones are called pi's. And it doesn't matter if you put the sigma on the bottom or the top, who cares, all right? So this one we have 2 sigma and 2 pi bonds. Sigma bonds are hybridized SPs, all right? They're hybrid bonds. They're like S and P orbitals combined between the carbon and the other atom, okay? And then pi bonds, they're leftover P orbitals, all right? So these pi's are leftover P. So there's your first hint. We're going to have 2 SPs, and we're going to have 2 leftover P orbitals. What do I mean by that? Let me move right here. And this is how carbon would normally look. 1s, if we're drawing an electron configuration, 2s, up, down, and then 2p, up, up. That's carbon, 1s2, 2s2, 2p2, right? So when we look at this model we've drawn, we know that this is no longer the orbitals of the carbon atom. This is a carbon atom by itself, okay? But when carbon, in this situation, is bonded to these 2 oxygens, you have 2 sigma bonds. So that means you have 2 bonds that are collapsed between the 2 P's and the 2 S's. So what we do is, we say, okay, we have this SP. See, sigma bonds are hybridized SPs. So we have SPs, and how many of those do we have? 1, 2. Amp, amp. And pi orbitals, these are your leftover P's. So up here we're going to have 2p, up, up. And this, 1, 2, 3, 4, 5, 6, we still have 6 electrons. This is the electron configuration for that carbon. All right? Now if you're confused, don't worry about it. Stick around. Stick around. There's lots more fun to be had. Yes, I realize you probably don't think this is fun. All right? CBr4. We're going to do this one. This is the next one. Carbon tetrabromide. So we would draw it like this right here. Okay, let's not forget our leftover unbound pairs. Now, sigma bonds are always the first bond between two atoms, so guess what? Here we have two sigma bonds. Now let's go back. How did this carbon atom look in the first place? It looked like this. You should know this. You know this. This is how carbon looks in the first place when it's neutral by itself. But this carbon now is bonded to 4 different bromine atoms. So it now has its valence electrons are now in 4 separate hybrid sp orbitals. Sigma means sp hybridized. So we're going to change this. We're going to say, oh, okay, up here now we have sp, boom, boom. We have 1, 2, 3, 4. 1, 2, 3, 4. Now, the way this is labeled, or what it's called, is this is called sp3. And I know it looks like it will be called sp4, but you need to think about it like this. S, P, P, P. And another thing to think about is, could we ever have more than 3 P's? 3 different P's? Not really, because there's only 3 different X, Y, Z, right? There's only 3 different dimensions. So you have 1, 2, 3, 4 SPs. 1, 2, 3, 4 SPs. And you call it SP3. All right? Boom. Let's try another one here. You should be catching on to this by now. H2CO. H2CO. Let's look at C dash dash O. Our H's will be like this. And there we go. That looks pretty good to me. Some organic chemistry professor could probably argue with me or tell me these H's should be maybe more up and down. They're probably right. This is high school, so we're doing a pretty good job. All right? Let's look at this carbon atom. Sigma is the first. Sigma is the first. Sigma is the first, and boom, we got a pi. These 3 sigmas are what? That's right, they're sp orbitals, and this pi is a leftover p orbital. This carbon normally would have looked like this. All right? That's 1s2, 2s2, 2pt. That's the carbon before it was in this relationship. But now this carbon, it's 4 valence electrons. There's now 1, 2, 3 sp hybridized orbitals, and then a leftover p orbital. So we're going to collapse this and redraw it to what's actually happening with this carbon atom. So we have 2s, no, not 2s, good law. Come on, get your head in the game. Sp, how many sps? 1, 2, 3. And then 1 leftover p orbital. That's it. 1, 2, 3. 1, 2, 3. 1 leftover p orbitals. Boom. So this would be called sp what? That's right. That's sp2 hybridized. You can think of it as spp because the first one's still considered an S, and the rest are the P's. So this is sp2 hybridized. sp2 hybridized. So that is how you do it. I'm going to throw one little thing here on the end so I can ask you questions, and maybe this will be a head puzzle, who knows. All right? How about this guy right here? CS2, carbon disulfide. What would this carbon end up being? You may have to draw it home or think about it. This carbon would end up being sp hybridized or sp1 hybridized. Okay? Just like CO2. What if we had CH4? What would that end up being? That's right. sp3 hybridized. If you don't know what I'm doing, you can draw this molecule and actually do the whole thing and figure it out. It'd be sp3 hybridized. And then how about how about H2CS? And that would end end up being, let's see, we have 1, 2, 3. Again, well, let's draw this from our brain. Boom, 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 right? Boom, boom, boom. So you have 1, 2, 3 sigmas and a pi. That's going to be sp2 hybridized. All right, there you go, people.